I want to introduce some other concepts to you related to the pictorial representation of the solutions of linear equations in two variables. The pictorial representation, the graph of the solution set of a linear equation in two variables, always creates a straight line. That's an interesting and important thing to remember. The picture, the graph of the solutions of a linear equation in two variables always creates some sort of straight line. And oftentimes, those lines cross the x and y axis. And the points where those lines cross the x and y axis are called the intercepts. If we consider the black line, which was related to this particular equation, the intercepts would be, the y-intercept would be the point 0,4. That's where the line crosses the y-axis. And the x-intercept would be the point 60. So for this equation, the y-intercept would be the point 0,4, and the x-intercept would be the point 60. Those are the points where the line crosses the x and y axes. If we consider the blue line, the y-intercept for the blue line would be the point here, 0, -4. The y-intercept here for the blue line would be the point 0, -4. That's where the line crosses the y-axis. The x-axis is crossed by the blue line right at this point, which is not a point that we can easily read. So to figure out what the x-intercept is, we can't easily do that from our graph. But what do we know? What do we know is the value of x here, or excuse me, what do we know is the value of y here on the x-intercept? Isn't the value of y there 0? Don't we know that at that point, at least the y value has to be 0? If the line, the blue line crossed the x-axis, right there the y is 0. Above that line, the y's are positive. Below that line, the y's are negative. Right at that line, the line being the x-axis, the y values are 0. So couldn't we let y be 0 and solve that resulting equation for x to figure out what the x value of the y-intercept, the x-intercept would be? Well, that's just a nice linear equation in one variable, isn't it? So when we add 4 to both sides, divide both sides by 3. So this is the point 4/3, 0. So the x-intercept for our blue line, our blue equation, the x-intercept is the point 4/3, 0. In fact, that's one way you can always find the intercepts. To find the x-intercept, let y be 0 in the equation and solve for x. To find the y-intercept, let x be 0 in the equation and solve for y. And you'll always be able to find the points where the line crosses the x or y axis. Well, that's kind of interesting. Look at this. The y-intercept was -4. Look at the equation. The equation has a -4 in it. Do you think that's a coincidence? Well, it's not. Anytime we write a linear equation in two variables in this form, whatever this constant is It's the y value of the y-intercept. So if we had a linear equation in two variables that looked like this, y equals negative 2x plus 5. This is in that form, which I called the slope-intercept form in a previous video, and that's the reason it's called the slope-intercept form, is because one of the numbers that stands out to us is the y-intercept. Whatever the constant is the y-intercept for that equation's graph. So this equation's straight line would cross the y-axis at 0, positive 5. So whenever you have your equation, your linear equation in two variables, in this form, the constant is always your y-intercept. And there's something else that this form tells us. And we'll deal with that in the next video that you should watch.